All right, so convert 60 degrees to radians, okay? So usually degrees are related to angles, right? So angles are basically a measure between two different lines, right? So for example, if I were just to do a quick example here, okay? Um, so this would be what we call a degree, right? So this would be a measurable degree. So it's the angle between two different lines, and we have a unit called degrees. There's another way that we can describe degrees, and it's called radians, and it's based around the circle, okay? Oh, I need to make my circle black again. Okay, so let's say that we have a big circle here, all right? And we're going to define its radius, okay? So we're going to locate its radius, and the radius is basically half of the diameter. So if we were to locate the center of the circle, which is around here, I guess, then the radius would be a line from the center of the circle to the perimeter of the circle, the circumference. All right, so this would be what we call the radius. Okay. So let me label this in orange, and we will call this R for radius. Okay. So like I said in our previous example here, the degree is a measuring unit to define the angle between two lines, right? So we can have that here. So we can have a line from here to here, from the radius to. We can have a line from with the radius and another line, and we can define that angle, right? So this is what we call. We can measure this with degrees. Okay. And we can also measure this with radians because of how the circle works. So if we were to rotate this line around the entire circle and meet back with the radius, we have measured the total degrees of a circle to be 360. Okay, so the total degrees of a circle is 360. Okay, but the equivalent to 360, or the total degrees, is what we call radians, and the total radians of a circle is 2 pi, and it has to do with something with the relation of pi to the circumference and the radius of the circle itself. So the total radians, and we have the convention rad for radians, is 2 pi. Okay, so this is an alternative measuring system that can be used to describe angles and also to describe the circle itself. Okay, so to convert between degrees and radians, we need a conversion factor. Okay, so the conversion factor for degrees to radians, or radians to degrees, is this. So how many degrees are in a circle? We have 360. And how many radians do we have in a circle? We have 2 pi radians, okay? And if we were to simplify this, we get pi over 180. And this is what we call our conversion factor, okay? So this is our conversion formula for degrees to radians, okay? If we were to convert from radians to degrees, then we would flip it and we would have 180 over pi. And a general rule of thumb is that the unit that you want to be converting to is at the top, and the unit that you're converting from is in the bottom, okay? So that's a way that you can always check to make sure that you're converting correctly, right? Conversion formula for radians to degrees. Okay? Another rule of thumb is that you want to be canceling out your unit that you are to convert it to the other one. Okay, so if we were to see it here in our example, we have 60 degrees and we want to convert it to radians. So we use this one, right? And why is that the case? Well, first of all, the unit that we're converting from is at the bottom, and the unit that we're converting to is at the top. Okay, so this is rad. Sorry. Second of all, if we were to go through with this calculation, we will be canceling out our units, right? We'll be canceling out these degrees, right? And we'll also be simplifying our here. We'll be also be simplifying our ratio here, I guess you can say. So 60 divided by 180, so that would be 3 and 1, and we get pi over 3 radians. Okay, so that's how you convert from degrees to radians, and if you want to convert from radians to degrees, you will use this conversion formula. And we found this conversion formula based on the total degrees of a circle and the total radians of a circle. Okay, so this solution is correct. Yes.